Okay, so on this one, you first have to decode what it says, and it's pretty clear. It's 4 log base 2 of 5 to the 4x equals log base 2 of 25 to the 8. There are many different paths you can take, especially on one like this. Let's try to take the shortest one possible. What do you want to do first? Someone raise their hand and tell me what you want to do first. Yes?
You can move the 4 to like a 5 to 16x.
You have to just be very careful. You have to do powers of powers. So it would turn into log base 2 of 5 to the 4x raised to the 4th power. That's correct. Log base 2 of 25 to the 8. And now you multiply it. That's correct. And it would turn into log base 2 of 5 to the 16x. And the only reason I put that extra step in there, it's really easy to do the wrong thing when you skip a step. It's so easy to do that. Now that you have that, what can you do now? You can't divide by a log, but if this is true, what has to be true? Pang. Well, what can we do first before we do that? You can't divide by a log, but if that's true, what has to be true? Yeah, exactly. Now, I just wanted to get rid of the logarithm. That's what get rid of it. So now, what is 25? Powers of powers. So therefore, 16x has to equal. So x equals. Bingo! Lots of different ways to do this. My target usually is get rid of the log, get rid of the log, get rid of this, get rid of it. And you should also immediately, though, when you look at this, the first thing you should see is 25 is 5 squared. I'm going to use that at some point. Making things smaller, helpful. Yes?
Is it okay like what I did after...
Articulate, articulate, articulate. Yay. So which formula we're using on this? Can one person tell me? And you know that because why? Continuous interest. What are we solving for? We're solving for r, so we need to plug in values for everything else. And we do have every other value. What's a? Yeah. P is? What's our t value? Yeah. So now you just solve this. What should you do first? Yeah. So you know e to the 8r is equal to 379 over exponent form. Let's translate it into log base of equals. So r is equal to 1/8 ln of 379 over 200. If you do this out, your r will come out to be 7.99%. When the person designed this question, what did they probably do? They just plugged in, not 7.99, what did they plug in? Yeah, which is about 8. And I bet their final answer wasn't 379. I bet it was like 379 and like $0.005, like less than a cent. So they rounded it to 379, a little bit less. So the interest rate is going to be a little bit less than 8%. Does this make sense, everybody? It's about 8%. Does that make sense? So again, a money problem, but really what kind of question is it? Logs and exponents. You need both. You need both in order to do this question. Absolutely. Okay, let's move on to the second sheet. Any thoughts on questions from the second sheet that you want to talk about? Anything from the second sheet you want to talk about? Anything? What's the first thing you notice? Bases are different. On top of that, not only are the bases different, the bases are not... They're not powers of each other, yeah. They're not powers of each other. That just makes the answer probably is going to be complicated, ugly, right? What are we going to have to use? Say it louder. Change a base. What base do we want to aim for? Nah, we don't have to add in a third base. No, we don't have to add in a new base. We don't have to. Let's use 4. Let's use the smallest number. So we have log base 4 of x over log base 4 of 6 plus log base 4 of x equals 3. What's in... Now, at this point, you could try to add fractions. But let's do something first. What's in both of those? Log base 4 of x. So what can you factor out of both of those? Log base 4 of x times what? 1 over log base 4 of plus equals. Now this thing right here, everybody, this thing right here is just a number. So let's give it a name. What letter do we want to call it? Let's use z. Sure, we can use... It looks like 2. We have to be careful. Let's use... How about f? Just something you don't use too often as a variable. So what do we have here? F log base 4 of x is equal to 3. What should I do to both sides? What? Yes. Log base 4 of x is equal to 3 over f. So can you tell me, what does x equal? Done. That's it. Please don't fail in the algebra section, if at all possible. Over yesterday's many questions that I got when people were working on the review tests that you guys made, I would say over a majority of the questions didn't have to do with logs or exponents or money. They had to do with, how do I factor this? Or where did I go wrong? And it was something that had to do not with logs or exponents, had to do with just basic algebra. So just be careful. The easiest way to make a careless mistake on these is to skip a step and to think you're doing the right thing, and it's not. Okay, any other one? The what? The exponent. So you get x squared over y squared times y to the negative 2 over... Let's just do the top first. What does that become? What do you do with the negatives? What should you do? Just flip them, which is... you can. This is something you can just jump to. It's going to be x squared y squared, and then you flip them, but they make them positive, times what? X squared over. So that's going to be x to the over. So that's the top. So what now? So you have x to the 4th over y to the 4th all over 15y x to the negative 2. What can you do with that x to the negative 2? Put it where? And make it positive. What does the top become? Dividing by 15y is the same thing as multiplying by 1 over 15y. So what does this become? X to the 6th over what? Yep. There it is. That's good. Very good. How do we feel about these questions? Pick a different one. But if you haven't, who has done 7? Who has not done 7? Yeah, most of you. Please do 7. Anyways, there's tons and tons of ways for this to be done. First, let's write it out what we as we think it is. Just to make it clear, it's 4 log base 2 of 5 to the 4x equals log base 2 of 25 to the 8. Can you tell me one observation that helps you feel better about this? What's nice about this? Yeah.
They both have log base 2.
Same bases, you get a nice happy feeling. It means you don't have to go on a walkabout. Yeah, there's also a lot of numbers that are factors of each other, common factors, right? So let's go on the shortest path we can. What should we do first for shortest path? What do you want to do? Move the 4 up?
Or
So,
to like make it so it's possible.
If we move the 4 up, just keep in mind when we do that, which is totally fine, it's 5 to the 4x raised to the 4th equals log base 2 of... What?
5 squared to
Powers of powers, what do you do? Well, we can actually do two things here. If log base 2 of something equals log base 2 of something else, what do you know about those two things? Yeah, we're not dividing the log out. What are we doing? We're using a logical conclusion. So we know that, and we can multiply the powers. 5 to the 16x is equal to 5 to the... So x has to be 1. Pretty cool, huh? We combined a few steps, but that's okay. Other ones on this first page here. First page. Anything else on this first page? You can do all of them. You didn't run into any trouble?
Can you go over 8?
8? Sure. Did you actually try 8?
I just don't think I was interested.
That's fine. We can try it. That's fine. Say you just bought a brand new car for $500,000. You take out a loan to pay for it. How much would you have to pay each month if you had an interest rate of 5% a loan that lasts 30 years? This is a pretty straightforward question because you are paying off a loan. It's asking you how much the monthly payment is. That's the most common type of loan. You can use the formula directly. So which one is this going to be? A equals? Yep. So what is it? 0.05 over what? Why? Because it's 12 months. You're compounding it monthly. So starting amount of the loan, and then 1 plus 0.05 over 12, all raised to the what power?
30
times 12, all over 1 plus 0.05 over 12, raised to the 30 times 12 minus 1. Now here's the thing. We've done this a bunch of times. We needed to practice this because is it really easy to mess this up on your calculator? Yeah, you're going to make use of the STO command, the store command, and punch this out. We're not going to do it out, but you need to be able to do this. Does that make sense? Yes, so this is where the interest rate, is it working for or against you here? Okay, it's working against you. So please use that. Yeah, that one. You're paying more because your loan is getting larger. So the amount you owe keeps on growing. Like you chip away at it, but it grows when you're not paying it. It's working against you, meaning you're going to pay more than the initial amount. So you're going to pay more than $500,000 for this. You're actually going to pay probably significant more than $500,000. Maybe even $500,000 more than $500,000. Something is it about that? Yeah, that's pretty common on 30-year loans with interest rates like this. Very common. Yes. So one greater than the total number of payments. So let's do one of these to see what I mean. How much money are we putting into the account every period? How much money? Pick any number you want. $15. Thank you. How often?
Every month.
How long? 3 years. Sure. So there's no money in the account at the beginning of the first month. On the first day, you put $15 in on the first day every month for 3 years. How much money do you have in the account at the end of the 3 years? That's the question. So the S is equal to 15 times... Oh, that's not what I meant to write. I meant ratio, and we'll do that one last. It's not quite interest rate. Did you actually see the proof that I did out in the video? Okay. That's nice. Okay. Yes, I'm sorry. Go ahead. Calculator. If we do this out, 1 plus 0.05. Oh, 0.05 divided by 12 raised to the... Well, actually, that's our R value, right? That's our ratio. So let's store this as alpha R. So what are we going to do? It's 15 times what? 1 minus alpha R to the what power? 37. Oh, I want to not do that. And then I divide it by what? 1 minus alpha R. So what does that tell us? That's how much you get. That's how much you have in the account at the end. So what have we done? We put $15 into an account every month for how long?
3 years.
3 years. How many payments did we make? 36. What's 15 times 36? What is it? 540. So what does that tell us? We made $58.72 in interest. That's how much we've made in interest. So this is you're building towards an amount. The other one, this one right here, no, right there. What are you doing right there? You're taking away. You're starting in debt. You're starting in debt. And then the other one, the first one we learned, just the simple one, the base right here. This is just, remember we had this. What do we have? A equals P times 1 plus R over N to the NT. That's the first one we learned, right? What's that one? How many payments are you putting in? 1 payment. And what does it do? It just sits there. It's 1 payment and it just sits there. That's it. Does that make sense, everybody? It's one payment, and it just sits there and it grows. And this is compound, and what's a sub-formula here? If you compound it instantaneously, A equals what? T to the RT. This is continuous interest. Okay, going back to homework 18 here, are there any from the first page that you still want to talk about? Any from the first page? Anything else from the first page? What's one specific thing you immediately notice about this question? Not a same base. Also, in addition to not being the same base, what do you notice about the non-identical bases? They're exactly right. Well said. They are not nice powers of each other, which means that your answer is probably going to be not nice, particularly ugly. Now, now that we know that we recognize different bases, what are we going to have to do? We're going to have to use the change of base formula, right? We're going to have to use it. What base should we aim for?
10.
Do we have to add in a third base? We don't have to. What do you want to use? We could use 4 or 6. We could use 4 or 6. I like using the smaller number, so let's use base 4. Let's just use base 4. So it turns into log base 4 of x over log base 4 of... Sorry, log base 4 of x over log base 4 of 6 plus log base 4 of x equals 3. Now, there's lots of different paths. I'm going to try to show you the shortest path. Writing the least. It helps you, helps me. Everybody's happier. What is in each of those terms? Log base 4 of x is in both of them. So what can you factor out of both of them? And now, how many x lives in how many terms now? One term. Is that a plus? Yeah. I don't really want to write that number over and over again, so this thing right here, give me a letter.
B.
B? Yeah, I like that. There's certain letters that represent sets or look like numbers, so I try to avoid them. Z, F, unless I capitalize it. B is pretty good. So what is this? B times log base 4 of x is equal to 3. What do I divide both sides by? Yep. So can someone tell me what x equals? 3 over b. Exactly right. That's the shortest way to write it, right there. That would be totally acceptable. That would even be acceptable on the AP test, as long as you clearly stated what b equals. They encourage you to do that, actually, because it makes your work easier to understand. Much easier to understand. Are there lots of ways to make this much longer? So, it's a fake quadratic. This one you wanted to see? Okay.
For example, could you multiply log 10 times log 4?
Well, let's pick something other than log 10, because log 10 is 1.
Well, no, just yesterday when you were showing me how to do something, you had...
Log 10 plus log 4. That is correct. I had that yesterday when I was showing you something.
And that's the same as log 40.
Yes, that is correct. When you add logs of the same base, you multiply what's inside there. Yes.
So you can't multiply logs of the same base.
So you want to do like log of 6 times log of 4, like that. There's nothing you can do. You could take this and make you can do one thing, actually. That is equal to log of 4 to the log of 6. You can raise it to the power to make it look terrible. Yes?
You could go the other way if you have
All of these are reversible.
6 minus log
What other way are you talking about? I mean, you can factor things out. Like, say you have like log of... I'm sorry, what do you want to do?
I think that ends my question, but there was a couple of
S equals A.
Yep.
Um,
Yes, right there, yep.
okay, so R is always going to be like
The ratio.
Yes. So it's always going to be the interest rate over like
1 plus
whatever
the interest rate over the periodicity, yeah.
Okay.
Periodicity, I think that's the word. Per year, yeah. The number of times it compounds per year, yeah. It's always going to be that. 1 plus the interest rate over that. Yes, Gare.
Can you add exponentials with the same base? Because I always think
No. A to the 7th plus A to the 6th is just that.
Awesome.
No, you can. What you can do is you could do a to the 6 times a plus 1. You can factor out stuff. But no, you can't add them together. They don't magic. Here, that's actually one common mistake, is that you have you have 5. Well, no, I know why you do, because you have 5 rules for logs. You have 6 rules for exponents, right? And they look kind of similar, but they're radically different, and they tend to do this. You're right. Please don't. Next.
I've got one.
Yeah.
I'm curious about changing the base of logs. For example, log base 4 of 6 plus log base 3 of 2 equals x.
Log base
4
4
of 6
6.
log base 3 of 2.
Yep.
Um,
Yeah, what about that?
so,
What are you trying to do?
Change solve for x.
Where's the x?
Equals x. Sorry.
So you're just trying to combine them? I mean, you know what x equals right now. The change of base formula says, all the change of base formula says is log base a of b is equal to log base c of b over log base c of a. That's all it says.
Right, and so that's what I used.
But I don't understand what your question is. You need to give me a question.
Okay,
This
so
right
I
here,
need-
you've isolated x. Done. What are you trying to do?
Can you simplify it?
Can you simplify
Okay,
that?
so
Is that what you're asking?
yeah.
Like,
So,
is
like,
this
I
something
made-
you made up, or is this from an actual question?
This was from a quiz that somebody made for me yesterday.
So it's probably just, can you combine it into one logarithm? That could be a sentence right there. Sure.
So
Log
I made C12.
6. Oh, don't pick new bases. Don't pick new
But it says-
bases.
But you okay? Oh, I was told that you need to make that C whatever you like a common denominator. Or
You
common-
don't have to pick a new base.
Okay.
You can if you want to. What do you want to pick?
12.
We'll do both. 12, okay. Log base 12 of 6 over log base 12 of 4 plus log base 12 of 2 over log base 12 of 3.
Right.
Now you need a common denominator in order to add fractions. You do not have a common denominator.
So that's the simplest you can get.
No, if
Or-
you could log base 12 of 6 times log base 12 of 3 plus log base 12 of 2 times log base 12 of 4 all over, what's our common denominator? Log base 12 of 4 times log base 12 of 3.
Okay.
But that's intensely more big than you need it to be. Writing this out again, log base 4 of 6 plus log base 3 of 2. If you want to just combine that a little more cleanly, pick 3. Pick the smaller one, sure. So log base 3 of 6 over log base 3 of 4 plus log base 3 of 2. Ah, can we factor anything out here? You still need a common denominator, but it'll be a slightly less disgusting. Your common denominator this time would be log base 3 of 4, log base 3 of 4, like that. So now can you add them together? Yeah, you can, because you have a common denominator.
Okay.
But it's not going to make it any nicer in this case.
So was that just a confusing question?
No, it just, I don't know what the question was. You didn't give me a question word to go with.
Sorry.
Simplify, solve. It's already solved. I mean,
Right.
you use the change of base formula when you need to combine logs that have different bases. Understood?
Yeah, I think that's
Okay, any other specifics? The sentences you just wrote out. What do you got? Someone who hasn't asked the question yet. You're supposed to each write down 2 things. Everything's been answered? You have no other questions? None?
Will you receive more money when you compound continuously or some other way? Which one?
If it's the same interest rate,
Yes.
it's always continuously is the most money you can make.
Okay.
The more you compound, the more money you make.
Okay.
The more compound, the more money you make. So therefore, if you compound as much as you possibly can, which is continuously, you'll make the maximum amount of money with that interest rate, assuming you don't change anything else.
Oh.
What is the R
What
in
is
the
R
many
represent
deposits
in the
one?
asset
Ratio. That's what we talked about just a minute ago. That means R, oh, that's right. R is ratio. You can take a look at the notes earlier, watch the videos. It's the ratio between the terms, which is actually, you can write it's 1 plus the interest rate over number of times compounded per year.
So, okay, I'm just gonna-
That's correct, you are. Okay.